Hi guys, so in this video I'm going to go through some Unit 2 calculations, and this video is mainly for my students because this is the lab book they have. If you are studying Unit 2 somewhere else, then you will use slightly different numbers for the calculation. So for the pH probe titration, you've plotted your results and you've ended up with a curved graph like this. It's called a pH curve, and we want to find the middle of this vertical point, and the middle of that vertical point is known as the equivalence point, and that's when equal amounts of acid and alkali have reacted. And we want to go down from the middle of that vertical point to the x-axis to find out the exact volume of acid added. So you want to go straight down, and we are interested in this number. So plot your graphs on Excel first. You can annotate your graph using the shapes function and lines, and then get hold of this value here. So my value from my graph for the amount of acid used at the equivalence point was 22 centimeters cubed. So wherever your vertical line touches the x-axis, you put that number there. Then we need to calculate how many moles of acid were in that solution. So we do concentration. Our concentration was 0.2 of the acid, times by the volume used at the equivalence point. So my volume was 22. We divide that by 1,000 to convert centimeters cubed into decimeters cubed. Let's work that out. 0.2 times 22 over 1,000. Okay. So 4.40 times 10 to the minus 3. Okay, now we had a 1-to-1 ratio between the acid and the alkali that we used. So if you were to look at the balanced equation, if you don't need any big numbers in front of the acid and alkali to balance, then we say we have a 1-to-1 ratio. So however many moles of acid we have there, we use those moles for the alkali here. And we're going to use that same moles equation to calculate the concentration of the alkali. All we need to do is rearrange in terms of concentration. So we do moles divided by, this time the volume has to be the amount of alkali that we pipetted, which was 25 centimeters cubed. We're going to divide that to convert it into decimeters cubed again. Work that out, and we get 0.176. And units of concentration are moles per decimeters cubed. And lastly, how does our value that we calculated from our results compare to the true value on the bottle? Now, there was no value on the bottle. I had to ask the technicians because they made up the solutions, and they said the concentration of the alkali was 0.200. Now we know what the value should be. We can work out the difference between this value and our value by doing a subtraction. After we have that difference, we can work out the percentage error in our result by doing the difference divided by the actual value from the technicians and times it by 100 to convert this to a percentage. And for my results, I get 12%. So this is definitely a significant error, and it comes down to how accurately we did the titration.